In this video, we're going to talk about writing a series in summation notation. We'll look at a couple examples. So the first one I'm going to start with is this series here. So 3 plus 11 plus 19 plus so on and so forth up to 787. What we see is we get going up by 8 each time. So it looks like we have an arithmetic. And so what we want to do is we want to develop a formula for the general term. So a sub n is equal to 3 plus the common difference times n minus 1. Because when I go to write this up in summation notation, first thing I'm going to do is put in my general term. 3 plus 8 times n minus 1. Now because of the way I did it, I'm automatically going to start at n equals 1. Now we can check. If I plug in 1, 1 minus 1 is 0, so that cancels this part out, and it's 3, so that checks out. Now I do need to figure out what my upper limit has to be in order to end at 787, because n goes up by 1 each time until I get to 787. So what I'm going to do is I'm actually just going to plug 787 in for here and solve for n minus 1. Solving this for n, and I've done this in another video, so to save time, you guys can go ahead and try this if you want. You get n equals 99. So 99. So there are 99 terms in this series, and this is written in summation notation. One thing I'll point out, there are 99 terms, but notice if you do top minus bottom, you get 98. Whenever you want to know the number of terms in summation notation, it's always top minus bottom plus 1. What if we did this? What if our series was 1/3 plus 1/4 plus 1/5 plus 1/6, so on, up to 1 over 100. There's a really nice slick way we can do this. We can see that the term is 1 over n. We can write it that way. The only thing is I don't want to start at 1, because if I start at 1, that's going to be 1 over 1. So I got two choices. One is I could just say, okay, well I'm going to let n equal 3 and let it go up to 100. And so that'll work. It starts at 3, goes up by 1 every time till I get up to 100. Let's look at another way of setting up this summation where n actually starts at 1. And there's an infinite amount of ways to write a summation. So don't think because you did it different than somebody else, yours is wrong. I wanted to start at 3, but this is at 1. So I'm going to do 1 over n plus 2. So that starts at 1/3. The next one is 1/4, 1/5, 1/6, and I want it to go up to 100, but I'm only plugging in n. So I only need to go up to 98. Now remember, we said there were 98 terms. Actually, we haven't said that yet. There are 98 terms because 98 minus 1 plus 1 is 98. 100 minus 3 plus 1 is 98. So the big thing in writing something in summation notation, first you want to get your general term. So if, let's say we had a geometric. So 8 plus 4 plus 2 plus 1 plus 1/2 plus 1/4 plus ... Now if it ends in ... it's automatically infinite. So we already know the top is infinity. We need the nth term. For a geometric, it's the first term times our common ratio. Well, notice what's happening. They're getting cut in half. Let's write that on top. Each time. So we have a common ratio of 1/2 to the n minus 1. So that is exactly what I put in here. 8 times 1/2 to the n minus 1. Last thing I need is the starting. It's automatically n equals 1 because of the way I came up with the general term. If we check, putting 1 in, 1 minus 1 is 0, 1/2 to the 0 is 1, times 8 is 8. Nice thing about this one is we could even find the sum. We could have done it in the first one, but because this is infinite, it's the first term, which is 8, over 1 minus the common ratio, so 1 minus 1/2, which is equal to 16. You can check that out if you want to see how I got that.